stars. I just finished recording the lecture on is IQ heritable? And the answer is no, it is not. Intelligence is partly, very probably. And in that video, I alluded to different theories that are different than neo-Darwinism on biological change. And there has been a lot of activity in this among scientists and so forth over the recent years. And I want to talk a little bit about this in a book review that I did of Denis Noble's book. Let me make sure it's Dance to the Tune of Life, Biological Relativity. I wanted to make sure I got the subtitle right. It's a very good book outlining that theory of a new synthesis for biological change, moving past neo-Darwinism and so forth. And I want to talk about that briefly. I'm only going to talk about it a little bit, and I want you to go. It's a very long. There's two ways to do this, like I say in the write-up. You can do it a long way, and you can very carefully delineate each idea, each term, each word, each punctuation mark in this particular thing, because it's a very contentious subject. There's any number of people who believe and fall prey to the evolution fallacy, which says that if evolution is true, then God does not exist. And I've told us before, there's both atheists and a lot of theists also buy that argument, and it's completely false. And the problem, and the reason it's a fallacy and so forth is because the word evolution itself has no fixed meaning, and therefore you can't say is evolution true. That doesn't mean anything. And everybody knows this, but they keep using the word anyway, just like they use IQ for intelligence. It's one of these things we're using the wrong word because it's a useful shorthand word. It leads people into vast error. So if only we could talk about the individual causal theories and conditions that bring about certain biological changes, then we'd be in much better shape than all these different words and so forth. So I can go into all that. You can go into the whole thing, but basically then be writing a book. On the other hand, if I do a really brief article, of course the article still is a few thousand words, and so I'm still testing the reader's patience, but I can give you the grand view of this kind of thing and point you to other literature, but because the topic is so contentious, people get so boiling mad over it so easily. Why, I don't know. Probably because of the evolution fallacy, that there's no winning on this. There's no winning on this topic. So feel free. I'm going to do a shorter version of this. If you want to get angry and mad and sputter and all this kind of stuff and cast opprobrium and all that kind of a thing, please do so. But do it after you read the article and after you read Noble's book and so forth. So I'm going to read you something that he did. He was giving a talk on his ideas not that long ago, apparently, and he on the weaknesses and errors of neo-Darwinism. Okay, and he was suggesting his alternative theories for certain changes and so forth. And now he got, whenever you tell scientists new ideas, they are always dismissive of them. They're sniffy. It's either, oh, I always thought of that before, or it's not important, or it's wrong. That's just scientists. So he got that kind of reaction. So that's entirely expected. But here, what surprised him was this. I want to read you this little quotation here because it's relevant. A very distinguished neuroscientist who confided in me during the coffee break said, "I would go along with you, Denis, except that what you are arguing would let God back in. This was very revealing to me," this is Noble speaking, "since I certainly did not think that conclusion followed at all. Yet he clearly did, and had no doubt about it. In fact, I suspect for many scientists, defending reductionism, including particularly neo-Darwinism, was a necessity in order to counter the claims of creationist religions or supernatural intelligent design." Okay, so this distinguished neuroscientist, he willed himself to be ignorant in the fear of God. And even Noble uses somebody, in fact, he is not a theist himself by any stretch. It pleases him to call God she, and he has all sorts of other enlightened opinions in his book and so forth. But he is correct, I think, in his criticisms of neo-Darwinism, the causes and conditions involved in change, biological change and so forth. And he does admit the word evolution, he said, this quoting Noble now, he says, "The word seems to bring out Very strong passions in people, positive and negative. It is almost as though the less illumination there is on how biological change happened, the greater the heat of the debate. Not almost, Dennis. Not almost at all. It definitely is. But he has, the problem here is he uses the word himself. He uses the word badly. He says things like, evolution could use such mechanisms. How could evolution is not a cause? Evolution is not a cause in nature. Therefore, evolution can't use any such mechanisms. And he said during evolution, things like during evolution, when he meant over time. Now, these are just slips of the pen, if you like, for him. It's obvious when you read his book. He doesn't mean those things, but it's a weakness we all fall prey to, like using IQ for intelligence. When you let yourself do things like this, all of a sudden, I deleted this stuff, but if someone asks you, like, do you believe quantum mechanics? Do you believe in quantum mechanics? What does that even mean? Does that mean I must believe in Everettian multiverses or, all holographic theory? You can go on and on and on. Do I have to believe all this? Do I have to believe string theory? What do you mean exactly? State exactly what you mean. If you ask the question, do you believe in evolution? The question is meaningless. All right? It's nothing more than a religious test. You need to say, do I believe in this particular cause that operates on these substances under such and such conditions? Well, what's the evidence for it? Aha. Then we can talk about things, but not in these loose, dumb terms. And that's what hackles start to rise and so forth. Okay. Now, one thing Denis, like I'm pals with him. Okay, I don't know who he is. I mean, I know who he is, but I'd never met the gentleman. One thing Noble argues, him and his brother are both involved in this work. He at least gets this right, and so my heart soars like a hawk when I was reading these things. He knows that randomness is not a cause. Chance is not a cause. Randomness and chance are just synonyms for our ignorance of what causes are. Random chance is a double dumb synonym to excuse that we don't know what brought about a particular cause or a particular change. And so he knows that randomness cannot be this. He says, change is not random with respect to location in the genome, noting that if all locations in the genome were equally open to changes, there would be no possibility for a functionally relevant change, and that's absolutely true. There is change in the genome, now I'm quoting, there's change in the genome by combinatorial selection of alleles, not selection of new random mutations. Okay, so every time you see someone wave their arms about randomness and so forth, they're bluffing. There's a lot of bluffing going on in neo-Darwinism. There's just tons of bluffing, but we'll cover that another day. And here's what I really liked about his book. He and his fellow people who are telenomic evolutionists, if you like, or whatever the word they're coming for themselves, they have rediscovered substance. We've talked about substance many times before. The classical idea of substance. A thing has an essence, a quiddity, a whatness. And there is an essence to a thing and our knowledge of the essence of the thing. So there's the ontology of the thing and there is the epistemology of how we know about things. And we must always be extremely strictly careful to separate those two. Otherwise we commit the deadly sin of reification. Okay. But he has discovered substance. And if you don't believe in substance, you think everything is a machine. You believe in the machine metaphor, which is reductionist. That's why he was talking about neo-Darwinism being a reductionist theory. It's Democritean. Everything is atoms in the void. Everything is just simple atoms, if you like, bumping into each other by well-known laws of the universe. And that's it. And that produces everything we see. That's not, of course, what we see in real life. That's not what life is. Life is not this kind of a simple-minded machine, even though that machine metaphor has been extremely useful as a metaphor in order to do certain things, but it breaks down really easily. And so he uses the example, maybe I should erase some of this stuff here, and I'll show you. I should have erased this beforehand. He uses the example, he likes salt. I like water. Salt has properties, in essence, properties, it has powers that a substance has. It has causal powers that operate under certain given conditions. Okay, and so does water. Water has all kind of power. It's the miracle chemical. I mean, the water is definitely a miracle chemical that is completely unlike the powers and essence of either hydrogen or oxygen. And the same is true. Noble uses Denis, because Denis is also a surname a lot of time, and I keep thinking it is a surname, but it's Noble. Salt is nothing like sodium and is nothing like chlorine. Almost no overlap. The powers of this particular substance, this is now a substance, and so is water. It's not hydrogen and oxygen doing whatever they're doing. No, it is now water. These, and the way that to think about, the way that we think about these things is that we say in water, hydrogen and oxygen are there in water, but only virtually. They're only virtually there. They're no longer there as individual substances themselves. They have become one. They have become their own substance. They have their own essence. And it's very simple. What we deduce from this is that the sum is greater than the whole, rather. My apologies. The whole, and here's the mathematical thing, is much greater than the sum of the parts. The whole is much greater. There's a little math symbol for you. Double greater than means a lot greater than. The whole is a lot greater than the sum of the parts. And that holds for everything. Now, for whatever reasons we can talk about another time, Aristotelianism was abandoned, and teleology was abandoned over the course of a couple of centuries and everything, and partly because, like that neuroscientist, they didn't want to have God in, and in doing so, they threw out all these useful concepts and embraced nominalism with a vengeance, and it came to error. Like I say, though, it was very useful in the beginning to think of things in a very materialistic way, as everything was a machine, and this allowed people to do all kind of things. But we're bumping up against limitations at this point in science. We're bumping up against what the machine limitations can do. If you had a perfect model of sodium and a perfect model of chlorine, you will not have a perfect model of sodium chloride. You won't be able to deduce the properties of salt from sodium alone and chlorine alone. And the same thing with this. If this sounds like Gödel kind of stuff in math, it is exactly the right kind of idea. These substances, if you like, occupy forms, and there's causes. We need to think about causes. This is Noble's idea of trying to bring back to biology these ideas. There's a core group of biologists trying to bring back, groping. They don't know they have rediscovered all of these things. They don't necessarily even know the names of the people that they're drawing upon, because classical education is now almost completely absent. And even for me, I went through the whole system, got a PhD, all this kind of crap at Cornell and so forth. I didn't have to take any of this. I didn't have to learn any of this. I didn't have to know any of this kind of stuff. I just had to make sure I knew all these mathematical equations and so forth. What it meant to apply a mathematical equation to real life, nobody ever said. That's a matter of philosophy, and it's not a matter of mathematics. But as long as I knew the math, I was okay. So we don't teach this stuff so people don't know. So they're trying to rediscover this kind of a thing. And now I lost my train. Okay, yeah, so we have cause. We have the material cause of things and the efficient cause. Another word for cause is explanation, synonym. Whenever we see something, we have to have an explanation for it. We have to have a reason for its existence, and that's the cause. So that's not the term. So we have the efficient cause, and together the efficient material causes of things are basically what people take as cause now. It's sort of an active sort of like a motor running or something. Active properties of causes and so forth. But that's not what cause meant originally. Cause meant the explanation for everything, the reason for its existence, why, the whatness of everything. So partly it's material, partly it's efficient, partly it's the formal cause, and partly it's the final, the cause of causes, the things that ties everything together, the essence of things, why things exist, why particular substances exist, and so forth. But here, science has left out the formal cause. The formal cause of things. A form, and we've done this before, so I'm only going to briefly go over this. A form, why isn't this scrolling? Oh, for crying out loud. A form is the essence of a part of the essence of a thing. The form of a thing, for instance, you could have, the very stupid examples, you could have a lump of clay and then you could fashion that into an ashtray or a plate or, into a statue or a bust or something. In each case, the form is different. The form itself is immaterial. The form is not material, not material, not material. Okay, it's not made of stuff. The form exists amaterially, exists outside of material nature. Okay, we all know this is true. It must be true because of even that stupid clay example. The form is something else. Okay, the form, informal causes, so that Rupert Sheldrake, I guess we talked about him before too. He was one of the scientists who was trying to bring back the idea of, I guess he has formic fields. He's positing fields, there's fields for everything in physics now, that sort of carry these formal structures, if you like, and help occupy, substance can help occupy these forms. I'll explain what I mean by that in a second. So we're not going to talk about that per se today. But science did itself a tremendous service by leaving this out. And they're trying to bring it back now. They're trying to explain how this might work. This sodium occupies a form. It has a formal cause. Part of the explanation of sodium has its own form, and so does chlorine. If this sounds like Platonic forms and so forth, or Aristotelian forms, yes, it does. Because that's exactly what we're trying to talk about here. There's a completely different form for salt. So if you buy the traditional scientific explanations and everything, there was a big bang, there was nothing, which exploded, right? And so for no reason at all, and all chemicals started off as nothing but hydrogen, and eventually we got, through all sorts of processes, these particular things. How did this, and the reason this is important is because there's a philosophical precept that effects cannot be greater than their causes. You cannot have a cause that produces something greater than the substance that you already have. The effect has to be from the cause. So how do you get, the objection to certain biological change would be, how do you occupy these new forms? A species is a form. A species is a set of animals that share an essence. Okay, that's our definition of species. It's not necessarily animals, life forms. A set of life forms that share an essence. That's what a species is. But that's a different form. So humans have an essence that's different than turtles or blades of grass. Okay, I think most everybody agrees on that. And they can't be nominalist enough to disagree with that. And so the question is, how do these new forms come to be filled? And Noble only offers a sketchy version of how this might happen. But it's important, it's crucial. That's the key. Because if effects can't be greater than their causes, and we have a new species that has arisen one way or another, here it is, a new species, which means it has its own essence, which means it occupies this new form, and the new form is amaterial. How did it get there? Well, the answer is the form must be pre-existing. The form must be existing. And where do these, since they're amaterial, where do these forms exist? They exist in the mind of God. That's the classical solution to these problems. And it works in biology too. But they tried to get rid of it because they wanted to prove that if evolution is true, then God doesn't exist. That hoary old evolution fallacy. Okay. So, like I say, he goes on about sodium chloride. I go on about dihydrogen oxide. In other words, salt and water. It's much better to use their real terms, their real names, because the sodium chloride of course, it's perfectly useful in formulas, all that kind of a thing, but you got to remember sodium N plus chloride is no longer the same as Salt is not sodium plus chloride. It just isn't. It's a different species. So you got to be careful of your words. Okay. Now, the machine metaphor again. Let's continue to and wrap up this machine metaphor here. DNA, for instance, the center of life as DNA. That's what a lot of people say. People like Dawkins say genes are selfish. He says this is illusory. This idea, quote. The illusion has become so strong that many people think we know exactly what a gene is and how genes control the body. Recent experimental work in biological science has deconstructed the idea of a gene, and an important message of this book is that it has thereby dethroned the gene as the uniquely privileged level of causation. Causation to noble is relative, meaning not just bottom up, but all at once systemic. And he has a nice picture, and you have to look at this. Genes are not in charge. Genes are just a template. The organism calls upon genes. And the genes are there in the body, but only in a virtual sense. All right? The body operates as a whole. There's all kind of things going on inside an organism all at the same time. All controlled not by a bottom-up reductionist approach, but by a whole. By a whole. The whole thing at once we need to understand. And particularly in the case of man. Man is the most complex animal there is. And it is quite obvious in our case that we are not machines. I mean, unless you're a die-hard materialist, there's absolutely no way to do this. Okay. He says things like, we've looked at this kind of stuff before. They've done all sorts of work before, trying to find certain genes for things, single genes for very complex behaviors or phenomena or even disease and so forth. Had almost no luck in this because very few, not all, very few though, are the genes, specific genes for this or for that. All right, it's just not that simple because when you do cutouts of cutout experiments and so forth, you find other genes that then begin to express themselves to duplicate what was or is now missing in these cutout experiments and so forth. So the organism as a whole reacts, and the organism as a whole is sort of self-correcting, if you like, up to a point. Of course, you keep lopping off parts, and all of a sudden you have a dead creature instead of a live one. And you don't forget, things like there was this idea of junk DNA and all this kind of a thing. He said genes are templates; they're called upon. They don't command. He said if the word instruction is useful at all, this is quoting, if the word instruction is useful at all, it is rather that the cell instructs the genome. As Barbara McClintock wrote, the genome is an organ of a cell, not the other way around. Passive causality by DNA sequencing acting as otherwise inert templates, and active causality by the functional network of interactions that determine how the genome is active. I think a better word is accessed here than that, but that's fine. You get the idea. Butterflies used to be caterpillars, and Noble says, it's as though the genome contains the templates for two completely different organisms. Of course, more than as if, definitely, or as though, because it's absolutely true. All right, so you'll go and he has a picture, he has a show how this all flows and so forth. And I'm going to skip all that, and there's another picture about looking. I'm not defending. Here's the thing: I'm not defending all these new ideas to any real level or anything. He shows the ideas, the causal ideas, under neo-Darwinism, which is slow accumulation of mutations over time, which can't be reconciled with the totality of evidence. Small mutations are almost always harmful, or you can't see what they're doing and so forth. And instead, what we often observe is large changes. No one has observed a speciation. And people say they do, that it's always a bluff. They always assume that the evidence they see is proof of what they have claimed. but no one has ever, no one's ever created life in the lab, or no one has ever created a species in a lab or anything like this. Basically, though, the idea is, take dogs. Dogs, for instance, look at the enormous variety of dogs. The variation in dogs and so forth, from the tiniest little ones to the most massive one. They're all dogs. They all share the same essence of dog. And basically, there's so much going on, if you like, in the genome. The map of that genome is incredibly much larger than the simple-minded addition would have you believe. And we could see this in the animals that we know. So we've seen all of these kinds of things happen. We've seen these great variation inside of a species, but we haven't seen a speciations and so forth. So he gives ideas how this might come about. And I'm just gonna mention some of these. I'm not defending any of them, because I don't have the capability to do so. And the point is not that any of these I'm saying are right or wrong. It's that neo-Darwinism itself has to be false. It can't be, that is to say, I don't believe it's true. There doesn't seem to be enough evidence for it, and there's all sorts of errors piling up. There's book after book of neo-Darwinist criticisms coming from, because the objection has always been, well, that's because they're trying to drag religion back in, which is, of course, the genetic fallacy, a stupid argument, but made all the time, but by people who are themselves not theists, like Noble, who try to bring these things up. But you saw in the beginning, they get pushback because they don't want God to come back into the question. Well, there's things like epigenetics and so forth. There's the old idea that the gametes are shut off from the rest of the organism, and so once they're made, there's absolutely no changing them. And so, but if you believe they can be changed, then you're talking about a form of Lamarckism. A form of Lamarckism, not exactly the theory of Lamarck. And of course, that's what biologists are coming back to. This separation, this wall that supposedly exists, doesn't seem to exist. There's been lots of experiments to confirm, it seems, that you can change an organism by its environment in life, and therefore cause it to occupy a greater range of the variability and so forth. So there's multi-level selection, genomic evolution, niche construction, replicator theory, evolvability, and all this kind of a thing. And I go into, I have little quotations and so forth and everything. I don't want to make this speech about this. I want to make this speech about how do we understand things, and particularly how we understand how cause comes about. Because what happened, there has to be a reason. We see that there are different species. Everybody sees this. Different species, organisms that share an essence. Even if we don't understand what the essence is of every particular species, or as the essence is huge, our knowledge of the essence is small in any particular organism. All right, so remember, what is and what we know of what is are two different things. Something had to cause these species to occupy the forms which they occupy. Some causal process has to account for this. That's what they're trying to open up. The idea of small random mutations and all that kind of stuff, I think, is dying in the water. It never seemed quite believable anyway, because people wave hands about, oh, random chance. None of that's true. There's only causes. There's only causes. There's no such thing as that's confusing for your knowledge of things for what is. All right. So, and one of the big ones is this one here, inclusive fitness. This one always gets me. So I didn't go into all the theory itself, all those other theories that Noble's touting, that he's suggesting are good replacements. Because the point of all this is he's got all of these other causes, not just him, but a group of biologists. Here's all of these other causes that are operating. That's the new synthesis of biological change, he calls it. So you can call this the new synthesis. You can replace the word evolution with the new synthesis. But in each case, what we're really talking about is all of these different causes, which have maybe operating at different times across different organisms and different strengths in different ways, or even not at all in some organisms, and only exclusively in others, and so forth. So when you're just talking about evolution or the new synthesis, you're not talking about anything. You have to be very specific about what you mean. And because nobody knows what brings about a new species, how these new forms are occupied and so forth, although we do know from these examples that we can have effects that are greater than their causes if the forms are pre-existing. So we can apply these same ideas to biology. Now, a guy who done that, at least in a more philosophical sense, is Wolfgang Smith in his book Cosmos and Transcendence. We'll discuss that book a different day. But one of the big errors, I think, because man, they're always pointing to here's why man does this. All these evolutionary psychology ideas. Now, there's strengths and weaknesses with that. We're not going to get into this whole thing today. But this idea of inclusive fitness, it's based on genetics being king, everything. The emperor of all things, selfish genes and so forth. You won't die for, some other person, but you will for, 3 brothers or something. When the number of copies of your genes is greater in whatever this population is that you're suspecting, therefore, that's why we have altruism and so forth. This gets it entirely backwards. Inclusive fitness and all that kind of a thing is absolutely backwards. It commits the absolute deadly sin of reification. It is our model of how we look at things, basically completely different from the causal processes that are brought about. Okay, inclusive fitness just gets me. I'm going to quote Noble here on this. It is, of course, true that close kin often act altruistically towards each other, but there are nevertheless 2 obvious problems with the explanation. The first is that it clearly doesn't explain altruistic behavior towards other organisms that are not closely related. The second, like dogs, cats, we have pets. The second and even more serious problem is that it conflates the concept of selfishness and altruism at different levels. This is a mistake, since selfish or altruistic behavior at one level does not automatically guarantee such behavior at another level. So, for instance, in man, the big fad now are these men who enjoy sodomy, go out and adopt children, which are not genetically related to them in any way. How could adoption be? First of all, if selfish genes were true and inclusive fitness was true, there should be no adoption. There should be no abortion. There should be no of these strange, celebrated, even mandatorily celebrated sexual proclivities that are non-reproductive, but we do. So inclusive fitness is a correlation. It's a correlation, and we're not supposed to say correlations are causation, but inclusive fitness is. Okay. That's basically it. I only sketched. I can only barely sketched. I want you to I have a paper that, I have a link to Noble's paper on the same subject. There's all sorts of other people who are working on this. And his book is very readable. It's designed for a scientifically literate audience who are not necessarily biologists. In fact, the first, almost half the book, 40% of the book or something, is an introduction to biology and all these sort of ideas of, what's going on. And then only then does he bring in all of these other ideas and so forth. I more or less figured that my audience is mostly already biologically literate, so I skipped all that and moved just to the philosophical parts of it. And I didn't want to go into the scientific parts of it, all these causal discussions of Evo-Devo theory or epigenetics and so forth, per se, because each of those would involve long discussions, and those are beside the point, because we need to understand why, I think, there's resistance to even looking into these ideas, is because people have a lot of wrong ideas in their head. They get the idea of the ontology and the epistemology mixed up. They have an absolute fear of classical causation, and they are religious and want to keep that, and they're beholden to the evolution fallacy and all that. Okay, you can go and read the rest of it. It's a very long essay on wmbriggs.substack.com, or you can just buy Noble's book. I think you'll find it's worth it. Thank you very much for listening.